Hello everyone, welcome back in this another episode of Problems You Must Try. Today's problem is from limit. We have to evaluate this limit x approaches 0 plus, for which the function is given as -1 plus a square root of tan x minus sin x plus a square root of tan x minus sin x. There's a nested function there up to infinity, and denominator is also on the same structure with x cube. So for that, first of all, we will try to understand why this limit is not 1, because the obvious temptation we have, the natural way of thinking, many students can think like that, or they have actually thought like that. Tan x minus x, when x approaches 0 plus, that whole square root term will going to be 0, and we are left with -1 by -1, and that will give you 1. But is not the correct answer. Instead, the answer is different. So we'll discover what the answer is. But before that, let us understand what is the meaning of tan x minus sin x when we approach towards 0. So when I say limit x tends to 0, tan x minus sin x, the tan x is always greater than sin x. So when we are still approaching towards 0, the tan x is higher than sin x. So this will give you some gap, means we are comparing with, let us say, with x cubed. Then the closest approximation we can take at x cubed. So here what is happening, that tan x minus x sin x has some value, and we are taking the square root of the same value and adding to it. So when we take the square root of any value lying between 0 and 1, it will be greater than the previous value, means the original value. Means root of tan x minus sin x will be higher than the tan x minus sin x itself. It means we are adding some value, so we are not decreasing the value, instead we are increasing the value. So it shouldn't approach towards 0. Therefore, the answer cannot be 1. So I suggest you try to understand this scenario. First, this is tan x minus sin x by x cubed. Suppose I have a limit to evaluate. There are two ways to do it. The first way is by using the series of tan x. I need only first two terms. So that is x plus x cubed by 3. And the sin x has the series expansion, the first two terms, x minus x cubed by 6. Because I'm comparing with the denominator x cubed. So we'll do that. And what we're getting here is limit x approaches 0. The tan x is x plus x cubed by 3. Minus sin x is x minus x cubed by 6. And divided by x cubed. So we are getting the limit x approaches 0. The x and x will get cancelled, and we have x cubed common. That is also going to be cancelled. So basically we are getting 1 by 3 plus 1 by 6. And this is going to be 6 and 2 plus 1. So answer is 1 over 2. Now I will suggest you to memorize this result. We often encounter this kind of expression, tan x minus sin x. Let's say when x tends to 0, what will happen? And we have, instead of series also we can do better. Suppose you don't have a good memory of the series, you can also apply this thing, limit x approaches 0. I can write this tan x as sin x by cos x and minus sin x. I can take this sin x out, and I will be having 1 minus cos x by cos x for limit x approaches 0. It means that I have now limit x approaches 0. Sin x I can write x, because the sin x is approaching towards x when x is approaching towards 0. The cos x has no contribution in making this 0 by 0 format. So I can directly write 1 there. And 1 minus cos x, I can write 2 sine square x by 2. So better approximation for this limit is not 0. Rather, again I have the 2 out there, and sine x by 2 times I have. So when x approaches 0, each sine will approach towards its angle. So we can write x and then again x by 2 times. So we have x cubed by 2 as its approximate value when x approaches 0. So whenever I see the tan x minus sin x expression anywhere, I can directly write it as x cubed by 2. In fact, there was one question. It was asked perhaps this year in JEE Main. The tan x minus sin x divided by tan x minus sin x. I will come to that question. So how we can approach this one? We know that I have this approximation exactly. We have just found that is x cubed by 2. So I can directly write it as x cubed by 2. And this tan x and sin x, I can take the better approximation by using its series. So tan x, because the argument of the tan is tan x, I can write it as the first two terms of the series expansion, of the tan series expansion, that is tan x plus tan cube x by 3. And for the sine, we will do the same thing, that is sin x minus sine cube x by 6. Now you see what will happen. We can directly write this thing. Limit x approaches 0. This tan x from here and this sin x from here, I am clubbing together. It means it is going to be tan x minus sin x as one bracket. And from there, I am writing the tan cube x by 3 and plus sine cube x by 6. And this is going to be x cubed by 2. Now, everything is well and good. That is tan x minus sin x again. And when x approaches 0, I can write this thing as x cubed by 2. And this is again, you see this thing. When x approaches 0, this tan x I can take to x. And this sin x I can also take to x. So there is x cubed by 3 plus x cubed by 6 again. So x cubed by 3 plus x cubed by 6. And there x cubed by 2. So I will get all the x cubed cancelled, and I have 1 over 2, and this is already we have evaluated. This is also 1 over 2. So we are getting here 1 over 2 plus 1 over 2 in denominator, and there is 1 over 2. So therefore the answer is 2. So this was the question asked in JEE Main 2025. Now we back to this question. How we apply this whole technique what we have learned to find out the exact solution of exact limit of this question. So what we can do better is this. You notice there that we are dealing with this situation. Limit x approaches 0 plus, I have minus 1. And this tan x minus sin x, because there is a x cube, we are comparing with the denominator. Why not I can write this tan x minus sin x for x approaches 0 plus as x cubed by 2. So let's write it. X cubed by 2 plus x cubed by 2. And it goes up to infinity. And there's one more square root here. And there, minus 1 plus square root of x cubed plus x cubed plus dot 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 infinity. The idea is that I have two different square root nested series. So for that, I'm taking the first one as a t, let us say. T I'm taking as a square root of x cubed by 2 and plus t I can write. You have done this kind of questions many times, so it's not like a alien thing for you. You can square it. So t square minus t minus x cubed by 2 is equal to 0. So basically in this limit, what I'm going to do is, it is minus 1 plus t I'm going to write, and then again minus 1 plus different value u. And when I'm finding limit x tends to 0 plus. But remember one thing, I'm going to substitute because I have not changed this variable. I have to write the t again back in terms of x as well as the u back in terms of x. So I'm evaluating the value of t in terms of x, and at the same time I'm approximating that value of t. So for that, let's find out this t by using the quadratic formula. There's going to be minus 1 minus plus and a 1 plus 2x cubed 4ac and divide by 2. You notice one thing, if I take this value as a minus sign, so basically it's a 1 minus 1 plus something. So this will lead us to a negative quantity. So t cannot be negative, so I'm avoiding taking the minus sign. So t I'm taking as 1 plus square root of 1 plus 2x cubed by 2. So here the t I have taken, and now I'm going to substitute it back at this place. But better what we can do, since I know that I have to substitute this t, this guy, I will approximate this t here only, because I know even the t I have to find, the better approximation for x tends to 0 plus. So what I can do there, this I can write it here as 1 plus 2x cubed to the power half and divide by 2. And so I hope that you know this binomial expansion for any index. So 1 plus x to the power any index n is 1 plus nx plus n into n minus 1 by 2 x squared and so on. But I don't take the higher degree terms because the x is approaching towards 0, so they'll be very near to 0. So for that I take the first two terms, so that will give you 1 plus, and I'm taking the n value half. You can see that this n is half, so this 2 will go away and I'm left with x cubed. So this will give you this situation on the top and divide by 2. So that therefore I'm getting here 2 plus x cubed by 2. So there is 1 plus x cubed by 2. Now notice this is the value of t we got. Can we get the value of u as well? Of course. So you can notice there's a similar calculation we have. Instead of x cubed by 2 at this place rather, I have x cubed. But let's calculate it. So I have u is equal to square root of x cubed plus u. Therefore u square minus u minus x cubed will be 0, and so you will have this value 1 plus the square root of 1 plus 4x cubed and divide by 2. I am avoiding the negative sign, you know the reason. So what we get here is, again I'm approximating by the same binomial expansion of any index, that is u is equal to 1 plus it will be 1 plus half of 4x cubed. So that will be 1 plus 2x cubed divided by 2. So this will lead us to 2 plus 2, that is 1 plus x cubed. So the value of u, approximated u at the degree of 3 is 1 plus x cubed, and the value of approximated t we got as 1 plus x cubed by 2. So now the final part is that we have to substitute this value there and evaluate the limit. Limit x tends to 0 plus minus 1 plus 1 plus x cubed by 2. Remind you, this is the value of t approximated, and here also minus 1 plus x cubed. Here this is the value of u, the approximated. And when you evaluate it, this 2 will go away, and so I have x cubed by 2 by x cubed. So the final answer will be half, not 1. So this is the correct answer we have for this limit. I hope you understood whole process, the way we solved it, and the one result I always suggest you to remember that whenever x approaches 0, tan x minus sin x, take the x cubed by 2 as its closest approximation. So thanks for watching. See you in the next video. Stay math active.